Now it's time to talk about non-structural adhesives in module 12.
Let's discuss now the main non-structural adhesives. Let's start by the elastomeric adhesives. We have actually discussed this type of adhesive in the structural ones, and they can be in both actually. They can be structural or non-structural. That's why we are also discussing them in the non-structural part. Maybe this time insisting in another adhesive family that is used a lot for elastic applications. I am talking about silicone adhesives. They are in general used when we have very large movements, typical of applications where we have dissimilar substrates, for example metal with a ceramic adhesive or with glass. They are used to withstand or to bear loads, but also to seal. This is a typical applications. And as I said, one typical elastic adhesive in addition to the polyurethane is the silicone adhesive. In addition to be able to deform a lot, they are also very resistant to high temperatures, contrarily to the polyurethane adhesives. So they are typically applied in aerospace vehicles to protect the metallic frame. We bond the metallic frame with a tile, and the tile is adhesively bonded with a silicone adhesive. But we have to be careful with the creep part. They would creep at high loads. So you see here how a vehicle part is covered with ceramic tiles. All these square parts are ceramic tiles, and they are adhesively bonded with a silicone adhesive. I have here a smaller scale adhesive or joint that is similar to this real application. We have aluminum metallic part and ceramic substrate, and the two are adhesively bonded with a silicone adhesive. In this case, in fact, in addition to the silicone adhesive, there is also a rigid adhesive. This is kind of a hybrid joint where we put two types of adhesives. One to withstand low temperature, that would be the silicone, and another one to withstand high temperature and give more rigidity to the joint. In this case, it's high temperature epoxy. All right. Then we have the polyesters, the saturated one, because the unsaturated ones are thermosets. In this case, we are talking about thermoplastics. They have the ability to bond many types of materials. For example, they are used to laminate plastic films. But the main characteristic is the fact that they are perfectly transparent and available in film. That makes them extremely suitable for electronic applications, all right? Such as the one you see here in the case of the production of a mobile phone. Then you have the hotmelts. This is something that I'm sure you have used at home. They melt with the application of heat, and then we apply them in a substrate, and when it cools down, they harden and we have the joint. The strength is not very high, they cannot stand very high temperature, but they are used in many daily applications. I will make a small demonstration for you. So imagine we have a piece of wood and we want to bond it to another piece of wood. I have here my hot melt adhesive. This is a gun, all right, that I'm sure you all use, and with the application of temperature, it's melting the adhesive. You see, I applied. It's very, very easy to apply, nothing special. It's still in the molten state, and then you can put the other substrate on top, and quickly it will harden because it will cool down. and that's it. We have a joint, a single up joint with a very high strength, at least for me. Of course, it's not the strength of an epoxy adhesive, but still you can do small construction, small repairs, packaging, that kind of things in a very, very easy way. All right. So that's for a hot melt. Again, an image with a typical application. And finally, you have the inorganic adhesives. So we are talking about ceramic adhesives for very, very particular applications, for example, in electronic circuits that need to withstand very high temperature, or for actually an application that that is very broad, that is very much used, which is in civil applications to bond the tiles. That's an inorganic adhesive that they use. The key word here, or the key word, is that they can withstand very, very high temperature. We are talking about ceramic adhesive, but they are extremely brittle. So it's for very particular situations. To bond the tiles in civil engineering, we are not talking about a peel or that kind of thing, so it's perfectly adequate. But for transport industry, we would never think about using a ceramic adhesive. So that's for the non-structural adhesives.